So this is test 0, which is primarily focused on doing object-oriented stuff in C#. So one thing I want to say up front and try to be super clear about is this is a take-home test where you do coding, just like the labs, practice exercises that you've done. But this is the essential difference. And I need you to embrace this with me. You've got to do this one on your own. So I'm really quite happy to allow and even encourage collaboration on those other kinds of assignments. But for the test, this may be the only take-home test that we have, but if there are others, I would have the same expectation. This is the thing that makes it a test. I'm not going to make you code on paper. That's gross. You should code in your editor. But since it's a test, and I want to know, do you know anything? Can you actually do something on your own? I need you to not use AI, and I need you to not use other people. Now, you can use the internet. You can use documentation. Like, if you just hover over stuff in VS Code, it'll tell you stuff. But I really don't want you to use AI, and I don't want you to use other people in this room, or for that matter, like you can't email your dad and say, hey, do this code for me. It's a test. I need it by whatever date. Okay? So that to me would constitute academic dishonesty. I might not be able to figure out that you did that. But so that's what I'm saying. We're operating in a place of trust where I want you to work on your own and make sure that you can own this. So I'm saying if you can't do this by yourself, then you're not setting yourself up well for the rest of the class. All right. So if it's hard, then you come talk to me, and we can definitely talk about it, and I'll answer what I can answer. We may also have some discussion in this classroom together so that everybody's on the same page. Okay? So that's part of you accepting this test, is agreeing to do it yourself. All right. This first part is exploring inheritance. And we're going to model one of the most important games that humanity has ever invented, paper, rock, scissors. Rock, paper, scissors? Y'all say rock, paper, scissors, right? Somehow my elementary school brain learned it as paper, rock, scissors, and everyone makes fun of me for saying it in that order. So now if any of this is new, like I haven't talked about abstract classes yet, but I'm about to today. But I thought I'd throw out the test first so you see where you're going, and then you're going to see in the RPG that we're making, we're going to see abstract classes. So we're going to have a throwable object, which is an abstract class. Just as maybe I'll just go ahead and spoil it. An abstract class is a class that's just used for organization. You can't actually create an instance of an abstract class. So what's the point of it? The point is we're saying that anything that's a throwable object has a name and an emoji, and it has a dual method and a toString method. So we're going to see that paper is a subclass of throwable object. And you remember from the rules of inheritance, if paper is a subclass of throwable object, then what sentence can we say? Remember there's like a little verby thing that we put?
Paper is a throwable object.
Paper is a throwable object. Let's think about that. Is that true? Yeah, all papers, right, that you can throw, all the papers are, in fact, objects that you could throw. They're throwable objects. I don't have a great name for this, and so I just went with throwable object. Ideally, you'd have a better name for the thing that, like, what would you call those things? Are they moves? Are they? I still don't know a good name for that. What's a word that is a paper, rock, or a scissors? Around is when you, like, are they weapons in this game? They don't even seem that weapony. To me, they seem more like objects that can be thrown, where this is a throw. So I think, yeah, so I'm going to go with throwable object.
I think throwable object.
Thank you. I agree with myself and you now. Okay, so we see that paper, rock, and scissors, as you scroll down here, are all subclasses, children classes of throwable object. And the essential thing is, let me show you this. This method, dual, is an abstract method. What's an abstract method? It's a method that doesn't have a body. What? So I'm immediately thinking like it's a head with no body, which actually kind of fits here. So an abstract method is a method where you've defined this is what the method looks like. It has to return an outcome, which is an enum, which is either win, loss, tie. It's called dual. It takes in another throwable object, returns an outcome. But when a method is abstract, we give no definition to the method. There's no body. There's no actual code with the method. We're just saying when you subclass throwable object, you must provide a body, an implementation for this method. So in some sense, you can imagine that an abstract class is a class that's saying this class must be inherited. It can't live on its own. It's too abstract. It's not, the opposite of abstract is concrete. So we have three concrete subclasses, paper, rock, and scissors, that are below throwable. You see, the beauty of this is we know that the throwable object is an ancestor, a parent class to paper, rock, and scissors. So when we do this dual, we can take in any two throwable objects and evaluate what the outcome is. Is it a tie, a win, or a loss? So that's why here you see that the dual method doesn't take in a paper, a rock, or a scissors. Specifically, it can take in any of them because they're all throwable objects, because they inherit from throwable object. So we have this kind of, really this would become like a polymorphism where this throwable object can take different shapes. You okay with that? Okay. The other thing I did here is that we're going to have our throwable objects have an emoji. So we can pass in an emoji, a paper, rock, or scissors emoji. It'll just make it more fun to print to the screen. Each of these subclasses has a constructor, and in the constructor, when you create a scissors object, you pass in the emoji in the constructor to set what the emoji is. Also within that, you can set the name of the thing to scissors. Where did the name come from? The name is this property. So all throwable objects have a name and an emoji, but they get that. They inherit those properties from their superclass. So I don't know if this is helpful to you. So you can imagine here, I'm going to create a paper, create a rock, create a scissors. You see, I'm passing in the emoji character, and I can call battle between paper and rock. This isn't especially useful because really there should be some var result, right? So the result of the battle, oh, no, my bad. Battle is something I wrote down here. So battle takes in two throwable objects. We create an outcome, which is T1, throwable object 1, dueling T2, and then I just print out, is it a win, a loss, or a tie? Does this kind of make sense? What questions do you have on this part 1 about inheritance? Dual is this method from throwable object. That's basically, it's the only logic that you implement in this whole thing. This is a really tiny example. There's not much code here. So essentially dual, which you would implement in paper and rock and scissors, is going to say, if paper duels paper, then it's a tie. If paper duels rock, you got to think about order here, but I would say the order is, if paper duels rock, then that's a win for paper. So the win-loss ties in relative to the first one. Does that make sense? So the different logic is based on which one you're in.
About the string of emoji,
Mm-hmm.
do we just copy an emoji?
I think I actually, if you want to pass the unit test, I actually look for the specific paper emoji, rock emoji, scissors emoji.
So we'll be able to just paste them into
Yeah.
VS Code.
Yeah, so that's what I kind of wanted to show you this too, that it's cool that VS Code deals with these special characters like these emojis. So I think I actually want you should probably just copy from here if you want them, because I think those are like correct. So this is what it means to, this is a super small example, honestly. This is smaller than our RPG is going to be of inheritance. There's a second way of modeling many of these kinds of problems, and what I've done on the test is made them specifically two different versions of almost the same thing. So an interface is a mechanism that essentially implements the can-do verb. You remember inheritance does the is-a? Interfaces say this object, this class, has some ability. It can do something. So we're going to define an I-throwable interface. In .NET, the convention is to put an I at the beginning of the interface name. And you'll also see that many interfaces end in able, because they're explaining an ability that this class has if it implements the interface. So this I-throwable says, if you're I-throwable, if you can do throwing, then you have two properties. You have a string name and a string emoji, and you have one method, the dual method, where that dual method takes in some other I-throwable object. So you see how this is very, very similar to the inheritance example that we just saw, but this is a different way of implementing it, this really small example that I hope will help you see some of the differences between inheritance and interfaces. In interfaces, you're just saying if something is going to be I-throwable, it has to provide definitions for these properties and methods. You don't get anything from your parent. You're going to have to make it all yourself. So in this case, the paper class, this is a class, implements I-throwable. It needs then, if it implements the I-throwable, then it has to be able to provide meaning, to provide definitions to name, emoji, and dual, very much like before. Rock and scissors also have to do that. We're also going to have Chuck Norris in this, because he should be present in most any dueling system. What's that? Yes. So Chuck Norris is also I-throwable. I would assume it would be this. So we want him to have a name. I think there's a little man emoji or karate emoji that you can put in. I can't remember if I put that in the unit test or not. Chuck Norris beats everything except himself. If you do Chuck Norris versus Chuck Norris, your computer should just turn off, is what should happen. But we're not going to do that. We'll just say it's a tie. So here's an example of this same game done using interfaces. So we're going to take in two I-throwable objects, let them duel. We're going to look at interfaces some more later today as well in our RPG example. But on the whole, an interface is just a way of saying, this is a set of methods that if you want to be able, if you can do this interface, then you provide meanings, implementations, definitions for these methods or properties. There's actually several built-in interfaces to .NET, and by implementing interfaces that .NET provides, you could actually become like a first-class citizen. You can make your classes first-class citizens of the .NET universe. So for example, there's an interface called iComparable. iComparable. And that means you're providing a definition of what it means to compare two objects of your class and saying this one comes before this one comes before this one, or they come in the same place. And if you implement iComparable, then even on an object that you make up, some goofy object like throwables, like paper, rock, scissors, we could make it so that those are sortable. We could have student objects, implement iComparable, and make it so that when we can call the built-in sort method that Microsoft wrote and actually be able to sort our students by last name and then by first name, say. So it makes it so that we can opt in and give our classes abilities that other systems expect. And I think that actually sets up the next one, doesn't it? No. Okay, here we go. Part 3 is about structures, which we've already done something very similar to this with vectors. So with this structs, I want to define two structures, a position structure, which is just an X and a Y, and then a way to print out X and Y, where you've got parentheses, X, comma, space, Y, parentheses. You with me there? So we're going to print out the positions, but we're going to use our positions to also implement a line segment. You remember a line segment? A line segment is two positions. We're going to imagine that we do have a starting position and an ending position. If we have a line segment with a starting and ending position, we have a start point and an end point. We can compute the slope of the line, the midpoint of the line, and the length of the line. These are all read-only properties. Do you remember the read-only property is a property that has a getter, it doesn't have a setter. And in this case, all three of these are perfect read-only properties because we can compute them based on what's here. We don't have to store anything, we just do some math. Okay? For the to-string method of the line segment, I just want us to print out first the start point, comma, end point. How are we feeling? I mean, honestly, this is a lot easier than the vector thing. So this is a struct, and remember, what's the difference between a struct and a class? One main difference. Struct makes up a full copy. And what's the fancy word for that? It uses the word type. Anybody else? It has to do with the type of its type. It's fun to use type repeatedly.
I'm remembering reference. The opposite.
It is.
Is it
But that's
value type?
value type. So a struct is a value type, whereas a class is a reference type. All right. Part 4 is all about shapes. Don't you love shapes? I like shapes. So we're going to define an I-shape interface. The I-shape interface has no methods, apparently, and 3 properties: num sides, area, and perimeter. Those properties are kind of like methods. These are going to be, at least area and perimeter are read-only properties. And then we're going to implement I-shape 3 times in a triangle class, a rectangle class, and a regular hexagon class. So in this case, I mean, it is the case that every triangle, in this case, we could do this with inheritance. I'm actually really tempted to, but I guess I shouldn't change it now. you can do inheritance and interfaces at the same time as well. And sometimes that's useful. Notice in this case, though, a triangle implements I shape. So it is true that a triangle is a shape. And as such, it has a number of sides, it has an area, and it has a perimeter. Yeah? A triangle, though, has something additional, which is an array of type double of sides, and it should have 3 sides. Yeah? So if you define the 3 sides of a triangle, then you should be able to compute the area of the triangle and the perimeter of the triangle. You remember this? Like geometry, trigonometry, math. Similarly, if we have a rectangle and you pass in the length and the width, then you are able to compute the area and the perimeter. And same for regular hexagon. If you have the side, the length of one side, then you can compute the area and the perimeter.
The way this is looking, the way this is being, we aren't going to be overwriting the area and perimeter.
Since this is an interface, you don't inherit area and perimeter, so there is no overriding because they never had a definition. So you're providing the definition for the first time. So this is one level. So basically, with the interface, you're saying this is an ability that this particular thing has. And the ability looks like this, where there is a, I guess I should say, this is an integer number of sides. This should be a double area and a double perimeter. These should both be doubles. Yeah. The beauty, kind of the strength of the interface is that if we have something that has like a similar, I want to call it shape or API, like it makes sense that in our example, the RPG, it makes sense that different things can move, but maybe moving is different in different classes. Then an interface just says these things have this ability. Whereas in a class hierarchy, you inherit the ability, right? You by default, you just are able to do whatever your parents did. In some systems, it doesn't make sense. Like the children are going to do something very different from the parent. This isn't a good example. Well, yeah, this isn't really a good example of this. So because they don't do something that's similar to their parent, it's like a completely independent implementation, then inheritance doesn't make as much sense, and interfaces may be a better fit for the problem. The other big difference is you can only inherit from one class. You can only have one parent. But you can implement multiple interfaces. And that's what we're going to do in this scenario. I-equatable, well, yeah, I-equatable is a built-in interface that we did not define. Microsoft defined it. And when you implement the I-equatable interface, you're going to give a new definition, a custom definition of the equals method. So what we're going to say here is when triangle defines an implementation of equals, then we can take two triangles and say, is this triangle equal to this triangle? By default, any class is going to do equals based on reference equality. Are these pointing at the same memory address? But if you can imagine, if I've got a 7, 8, if I have this triangle, I have 3, 4, 5, and I also have this triangle, this is not the scale. Basically, it still has 3, 4, 5. This has 4, 3, 5 as its side length. Are those the same triangle? I'm going to say yes. Those are equal triangles. Now, these are two different triangles, right? In memory, it's just going to look like an array of 3, 4, 5. This one might be 4, 3, 5. Imagine we could have some any ordering. If these are the three sides, any combination of those three sides, I want to say is the same triangle. So I want to give a new definition of equals that returns true if it's any combination of the same three. Does that make sense? For a rectangle, it would be the same thing. If you've got a 3 by 5 and a 5 by 3, those are the same rectangle. We're going to say those are equal to each other, even though they're at two different memory addresses. Okay? So that's what I-equatable says, is I-equatable says this is how I'm going to provide a new custom definition of equality. I-comparable is what I mentioned before, which is a way of saying, of comparing one triangle to another triangle and saying, if we were going to compare them, this one comes before this one, or this one comes before this one, or they would be at like the same spot if we ordered them. So when we have these definitions, we implement these interfaces, our classes become kind of much more capable of being used in new, interesting, convenient ways. Like, for example, as soon as you implement I-comparable, you can sort an array, a list of your objects without having to write the sort code. You can just use Microsoft sort method and it works because it knows how to compare two things. All right, part 5, I don't care about this year, so it's going away. So now there's just 4 parts, and so they'll be worth about 25 points each. I think they're all about the same level of difficulty. Thoughts, questions? When do you think it should be due? I would give you at least a week is my kind of minimum that I would feel good about. And I am going to, cancel class on Thursday. So, you got that in your favor, right? It's the barbecue festival coming up, so that may make it more difficult to code, right? That's going to be pretty impactful. Rush is going to mess you up, perhaps. What's that? Definitely. Yeah, definitely. Looking at previous code is definitely allowed. November something? Ugh, I think that's too long. Let's, I feel like, yeah, next Thursday is about my upper limit, but that'll give us 2 days of class to discuss things. And I do want to discuss some stuff because I know there's several new things on here. So let's go with that. Let's, if you would, open up the OOP RPG. Okay, did y'all follow along on this OOP RPG? Excellent. Yeah, file, open the folder. So let's just like try to remember what we did here. We defined a character. And we said characters have a name, a health, a max health, and a position. They have this move to method. Okay, this is, I think, what I would like to change and improve about this. I would like to say that I have a character class that is the superclass for player characters and non-player characters. A player character is a character, and a non-player character is a character. Agree? The people, the entities in the game that are actually playing will have to be one of those two things. NPCs or, I guess, PCs? Does anybody say PCs? No, to player characters. So what I want to say is that that character is actually an abstract class. So I want to mark character with the abstract keyword. An abstract is a word, a keyword that says this class cannot be instantiated. It's just a class that serves as a container, an organization at the top of a class hierarchy. So here, actually, I see now, I want to call this player character, I believe, to be consistent. So I'm going to change player to be called player character. And I really want the name of the class, the name of the file, to match the name of the class that's in that. So you see, part of what we've got going on here that's useful is we've defined in character all the things that all characters have, whether they're NPCs or player characters. So let's go ahead and make that other one so you can kind of see that. I'm going to right click and create a new file for, can I just call it npc.cs? Or should I make it the whole word? Readability wise, it's probably better for me to say non-player character. Non-player character. I think I spelled that right. And then I'll make a public class non-player character that inherits from character. Like so. Is that too small to read? Or is that better? Okay, so this is going to push the limits of my D&D knowledge to know what NPCs can do that's different from characters. Did someone say same? All right, so in our base class, we've said that characters have a name, they have a health, and they have a max health, and they have a position, and they have a move to. We're going to create an interface. I'm going to right click and create a new file and just fully lean into this interface way. So I'm going to call this interface iMovable.cs. iMovable. So I tells us that it's an interface, and then we have the name. It's just a convention to put the I at the beginning just to make things better named. Okay, so in this public interface, iMovable, I'm going to say, what is it that a class has to be able to do to be movable? And essentially, we just have to be able to move. Yeah. So in interfaces, everything, all the methods that you put in an interface are implicitly public because that's the point of an interface. You're saying this is a collection of properties or methods, abilities that you have to provide definitions to when you implement the interface. So I'm going to have a void move to, and then position pause. You're like, I'll go ahead and spell it out. Semicolon. So you see this I movable. If we implement the I movable interface, then we have to provide a definition of the move to method. I kind of got ahead of myself last time, so now I'm trying to clean this up. Are all characters movable? I want to say yes. So that means that all characters here implement movable. The way that we do this in C# syntax is exactly the same as inheritance, with the colon and then the name of the interface. Now, let's see. Once I do this, I've said a character is going to provide the definition of I movable. I'm going to build this and just see what I get here. .NET build. Okay. The reason I'm not getting problems is because, because I wrote a move to method here. Okay. Are items movable? They very well might be. And actually, I already put this here. I forgot. Go with me on this. I'm going to delete this move to method because I want you to be able to see this. So I want to say that items are movable. And notice as soon as I do this, after I deleted the move to that I shouldn't have written last time because I got ahead of myself, what I want you to see is the compiler is now saying, you are saying that you're movable, but you have not implemented the interface member, the move to position method, like you said you would. Implementing an interface is entering a contract with a compiler to provide definitions to all of those interface methods. So the quick fix here, implement interface. I think this is a useful thing when you're dealing with interfaces, because now it will create the method that exactly matches the interface needs, which is it's got to be public, void, move to, and then it takes in a position. By default, it throws a not implemented exception, which will build, but not exactly be what you want. But here we probably would like to say the position, capital P, is equal to position, little p. So we're making its position equal to what was put in. Just to make this a little bit more fun, let's make a property here. Look back to character. Let's make a property called double speed. I think that's what you normally call it, right? Speed is how many units you can move per turn. Yes? No? So if you have a speed of 60, that means you could only move 60 in a turn. And now in our move to, we could actually implement the position and say, if the distance from where I am, so that's this position, actually here. Let's go into our struct position and write a public static distance between, and let's just take in two positions, position P1 and position P2. Does this make sense? And here I'm just going to do the distance formula, returning math dot square root of what, P1 dot x minus P2 dot x squared. Plus P1 dot y minus P2 dot y squared. So that's like the distance formula in one gross line. Why is this mad at me? Oh, this isn't void. Public static double distance between. So I'm writing this utility method to compute the distance between two positions. And this will be useful if I ever want to know what's the distance between two positions. Am I doing this right? P1 dot x minus P2 dot x times P1 dot x minus P2 dot x. So this is the difference in x's squared plus the difference in y's squared, and then I'm square rooting the whole thing. This looks right, doesn't it? So now that I have the distance between two positions, I've got an easy method for this. Then in my character class, I can say if distance between, I've got to say position dot distance between. If the distance between where I am, which is capital P position, and little p position is less than or equal to my speed, then update the position. Maybe otherwise, we should probably do something. You want to just say console dot right line that's too far to move in one turn. Semicolon. So what I wanted to point out here is that the implementation of move to for a character is different than the implementation of move to for an object. We're saying that an item can move around however it wants to. Okay, look, can we do one more real quick? I'm going to create a new file called iattackable.cs, iattackable. And this represents the ability to be attacked. So we're going to say, like, for one, like characters can be attacked, but items can't be attacked. They can't take damage. So a character, coming to the top here, is both immovable and iattackable. Oh, hang on. I didn't write this. Public interface attackable. There we go. What does it mean to be attackable? I think it just means you can take damage. So we have something like I don't need the public. Void take damage. and maybe int amount. Okay, on character, I've said that we implement iAttackable, but
you see, I have just iAttackable here, here.
Let's see, did we, on this public interface iAttackable, do you have a take damage method?
Well, type or name.
Let's see, did you make this iAttackable class and interface in a different file?
Public interface.
That's saved, it's in the same folder, in the same namespace.
I think I figured it out.
Okay, so here's this error again where we've said if you are going to be a character, you have to provide a meaning for this ability. And we haven't given it, so we can, quick fix is nice because then if we say implement, then it's going to write the method that definitely satisfies the interface. It's not what we want, but it's something. It'll make it compile. Now we say, what does it mean to take damage? And at the least, this would be something like health equals health minus amount. And then maybe we want to console.writeLine something like name takes amount damage. You with me? Just kind of logging what's happening. What I would like to impress upon you is that interfaces, I think, are actually more useful and more flexible, more reusable, more composable than inheritance. Because a lot of times inheritance is so strict because you have to satisfy the ISA. And a lot of times things aren't ISA relationships. It's a very high bar. Whereas, and if you have an ISA relationship, then you can only have one parent. So it works with the shape example that I gave you. You've got a shape, and a triangle is a shape, and a rectangle is a shape. But there's a lot of other situations where, to me, it's not quite as clear, and the ability to define abilities, which is what inheritance gives, is what interfaces give you, is the more appropriate, usable tool. So if we've got one, we are still, though, taking advantage of inheritance. Notice that a character is movable and attackable. And so because of that, that means that a non-player character now has that ability to move and to be attacked. But we didn't have to define it there. For what it's worth, I know I'm running out of time, we can actually also use inheritance among interfaces. This isn't a great example, but we could have a public interface I don't know, iRunnable, and we could say that iRunnable inherits from iMovable. So there's a move to, but maybe we also have a void run to. So if you can run to something, then you can also move to it. But I'm imagining here that run to, maybe you get to do double speed. So if you have the ability to run, then you can actually go twice your speed. Does that make sense? And maybe we would let characters, maybe characters are iRunnable, but NPCs are just iMovable. So if we were going to implement that, we could come over here and say iRunnable. Now note here, iRunnable essentially means you have to be able to run and you have to be able to move. So I haven't written I'm missing the implementation of run to, which I just had it down here. So in this case, I would probably need the same thing here and say if the distance between them is less than the, oh, sorry, I need a position here. Position P, a position. I'm sorry, I made this badly. This should have a position in run to. And now if this is less than 2 times the speed, then you can do this. All right, so we're going to stop and look at some stuff. The character just ran. Okay. So, do some good stuff on Thursday. Let me know if you want to carpool or you just want more information on the event that I'm going to at Jacks Creek for the meal packing. Be on the lookout for this test it'll have the 4 projects in the solution for you to start working on. I'm sure there's stuff that you'll need more information from me on, and I'm happy to share that, but just make sure you're working on your own. Thank you, guys.